Okay, let's have the solution to example 16. F is a 400 Newton force directed from point A to 1 negative 4 to point B 441 meters. Find the magnitude of the moment of F about the origin. Find the moment of F about point C with coordinates 342 meters. And find the perpendicular distance of F from point C. So first, let's write or resolve the 400 Newton force into its components. So this is a force in space. So 4 minus 2. So it is 400 newtons times 4 minus 2. So 2i plus 4 minus 1. So 3j. Then 1 minus negative 4, 5k divided by square root of 2 square plus 3 square plus 5 square. So 400 times 2i plus 3j plus 5k divided by square root of 2 square plus 3 square plus 5 square. Remember, the components of force is magnitude times components of distance divided by distance. So it is equal to 129.78I plus 194.67J plus 324.44K newtons. So we have the freedom to put the force along its line of action. It may be at A or at B. So because coordinates of B are all positive, so I'll place the force and its components at point B. So if this is the coordinate, if this is the first octant, we have the coordinate system. And imagine a box with dimensions 4 along X, 4 along Y, and 1 along Z. And the force, this should be point B here. And the components of force are right, up, and forward. So this is 129.78, 194.67 upward, and forward 324.44 newtons. And these are the components of distance. So first moment about the origin is, let's solve for the components MOX. So applying right thumb rule. So this is ignored because it is parallel to X. So this 324.44 would be positive. Use your right thumb. So the curling of your four fingers is the same sense as 324 times 4. So that's positive. Then minus 194.67 times 1. So MOX is 324.44 times 4 minus 194.67 times 1. So it is 1,103.1 Newton meter. MOY, so right thumb rule, right thumb towards the positive y-axis. So the moment of this x component is positive, 129.78 times 1, while the moment of 324 is negative. So minus 324.44 times 4. So MOY is 129.78 times 1 minus 324.44 times 4, negative 1168 Newton meter. Then finally, moment about Z, the positive sense is, remember, curling of your forefinger, right thumb towards the positive Z axis. So ignore this Z component, only X and Y components are considered. The Y component is positive, so 184.67 times 4 positive, while 129.78 is negative, 129.78 times 4. So MOZ is 194.67 times 4 minus 129.78 times 4. So it is positive 259.56 Newton meter. So the magnitude of the moment of the force about point O, about the origin, is square root of the sum of the squares of these components, and we'll get MOZ or MO equals 1627.4 Newton meter. So that's the magnitude. Square root of 1103.1 square plus 1168 square plus 259.56 square. You'll get 1627.4 Newton meter as the magnitude of moment about O. Next is find the moment of F about point C. So there's no instruction what type of moment is to be computed. So it is understood the vector form. But where is point C? Point C is at 3, 4, 2. So we have to locate point C relative to the position of the components of the force, which is at B. So because 3 minus 4 is negative, so C minus B, 3 minus 4 is negative, that means point C is left side of B. And 4 minus 4, 0, so that means there's no point, there's no, call this, uh, there's no y distance or vertical distance, so meaning the points B and C are on the same floor, same plane, xz plane. Then 2 minus 1 is positive 1. So imagine supposedly this box here, but it reduces to a rectangle, which is horizontal rectangle with dimensions 1 and 1. So based on 3 minus 4 is negative 1, so meaning C is left of B, but 2 minus 1 along Z is 1, positive 1. So C is in front of B. So you draw a box, rectangle, horizontal rectangle with point C left side of B, but point C in front of B. So if this is the rectangle with dimensions 1 by 1 by these calculations here. So B is here, so that B is mm, B is left side, right, or C is left of B, and C is in front of B because delta Z is positive. So C is in front of B. So the forces or force components are at B, Fx, Fy, and Fc. This is point C. So it's easy for us to compute the moment about C. So moment Cx by right thumb rule. So this component passes through, the Z component passes through Cx. So it is 0. That's parallel. So ignore. Only this component of force will have moment about Cx. And by right thumb rule, you position your right thumb towards the positive x-axis through point C. So it is positive 194.67 times 1. So that's MCX. MCX is 194.67 times 1. So 194.67 Newton meter. MCY, so apply right thumb rule, your right thumb towards the positive CY axis. So then the moment of 3 to 4 would be negative because the positive moment about Cy by right angle is in that direction. So it is opposite. So negative 3 to 4.44 times 1. The moment of 129.78 is also negative because it is in that sense. So if you look at the top view, both of these moment about C is, both of these are clockwise, and clockwise moments are negative. So negative 324.44 times 1, then negative 129.78 times 1. Moment about CY axis is equal to negative 454.22 Newton meter. Then finally, moment about CZ axis by right thumb rule, your right thumb towards the positive Z axis. So this is parallel, ignore. 129.78, if extended, passes through the extension of CZ axis. So there is no moment produced by 129.78. Only 194.67 will have moment about CZ, and that is obviously positive. So 194.67 times, if you look at the sense, it's the same sense as the right thumb rule. So 194.67 times 1, 194.67 Newton meter, MCG. So therefore, in vector form, M sub C is 194.67 I minus 454.22 J plus 194.67 K Newton meter. So that's the answer for moment of F about point C. And finally, the perpendicular distance of the force F from point C. Since moment about C, magnitude of moment about C is equal to F times perpendicular distance to point C, so therefore, since we can compute this value, magnitude square root of 184.67 square plus 454.22 square plus 184.67 square, that's moment about C. F is equal to 400, so we can solve distance, perpendicular distance to C. So substituting values, we get distance sub C, perpendicular distance to C, 1.0. 328 meters. So that's it.